Far beyond the familiar orbits of Neptune and Pluto, in the cold, silent reaches of our solar system, lies a shadowy frontier teeming with secrets, the Kuiper Belt. This vast expanse of icy bodies and drifting relics is like a cosmic attic, holding whispers from the dawn of our planetary neighborhood. But among its countless frozen wanderers, something strange lurks. 25 objects, each defying the rules, each hiding puzzles that have left astronomers scratching their heads. These aren't just ordinary chunks of ice and rock. They're anomalies, outliers, cosmic rebels behaving in ways that challenge everything we thought we knew about the outer solar system. Imagine a place where the sun is nothing more than a faint, distant star, where temperatures plunge so low that even time feels frozen. In this realm, some of these mysterious objects move in orbits so bizarre they shouldn't exist. Others shine too brightly or spin too fast or vanish without a trace, as if playing a cosmic game of hide and seek. What are they? Fragments of a long-lost planet? Visitors from another star, or something even stranger? The answers, or the lack of them, could rewrite the story of our solar system's past and hint at forces we've yet to understand. This is a journey into the unknown where every discovery raises new questions, and that's what makes the Kuiper Belt so thrilling. It's a reminder that even in our own cosmic backyard, the universe still has surprises up its sleeve. Together, we'll uncover these 25 enigmas one by one, exploring their oddities, the theories trying to explain them, and why they matter. Because out there, in the darkness, hidden in plain sight, lies evidence that we're only just beginning to grasp how little we truly know. Ready to dive in, the mysteries are waiting. The first of these cosmic oddities drifting through the Kuiper Belt has earned itself a haunting nickname, the Grey Ghost. Unlike the other frozen bodies in this distant region, this object moves at an almost lethargic pace, creeping along an orbit stretched so thin it resembles a needle threading through space. Most objects out here follow predictable, elliptical paths, but the Grey Ghost's trajectory looks like it was drawn by a shaky hand, looping far beyond where our models say it should. What makes this faint wanderer even stranger is how little light it reflects, just a dull, grayish glow, as if it's wrapped in some cosmic stealth cloak. Normally, objects this far out are coated in bright ices that catch the sun's feeble rays, but the ghost seems to absorb light rather than bounce it back. That dimness has led to wild speculation. Could its surface be blanketed in an exotic form of carbon, or maybe even ancient organic compounds left over from the solar system's birth? Then there's the question of its origin. Some astronomers argue it might be a rogue planetesimal, a leftover building block from the chaotic early days of planet formation, flung into this bizarre orbit by a long-forgotten gravitational tug-of-war. Others think it could be a colossal fragment from a catastrophic collision, a shattered piece of something much larger that once roamed these frozen outskirts. But here's the twist: if it is a fragment, why doesn't it match the composition of anything else we've seen out here? The Grey Ghost doesn't just defy expectations, it seems to revel in it. Every time researchers think they've pinned down its story, it throws another curveball, and that's what makes it so fascinating. It's not just an oddity. It's a living puzzle, one that might hold clues to the violent, messy processes that shaped our solar system's hidden corners. While the Grey Ghost moves with eerie solitude, another Kuiper Belt oddity couldn't be more different. A pair of objects so bizarrely intertwined, astronomers call them the Twisted Twin. These two icy bodies don't just orbit the sun, they're locked in a gravitational embrace so chaotic, it's as if they're dancing to music only they can hear. Most binary objects in the solar system move in predictable, synchronized patterns like graceful waltzers. But the Twisted Twin, their orbit resembles a tumbling coin, flipping and wobbling in ways that shouldn't be possible this far from the sun's gravitational influence. What makes this duo truly baffling is their sheer defiance of physics as we know it. Normally, closely orbiting objects settle into stable configurations over time, their movements smoothed out by friction and tidal forces. Yet these two refuse to follow the rules. Their paths twist around each other at odd angles, sometimes swinging startlingly close before veering wildly apart. It's the kind of behavior you'd expect from objects much younger, still reeling from a recent collision, not something that's had billions of years to calm down. That's led to one compelling theory. The twisted twin might be the broken pieces of a dwarf planet that met a violent end. Imagine an ancient world, perhaps as large as Pluto's moon Charon, shattered by a cataclysmic impact. The two largest surviving fragments, forever bound by their shared past, could have inherited this unstable orbit from the chaos of their birth. But here's the catch: if that's true, why don't other collision remnants in the Kuiper Belt behave this way? Another possibility is even stranger. Some researchers suggest the twin might not be local at all. Their orbital madness could hint at an interstellar origin, a pair of rogue wanderers captured by our solar system's gravity long ago. If that's the case, their odd movements might reflect conditions from an entirely different star system, making them cosmic immigrants with a story we've barely begun to decipher. One thing's certain: the twisted twin isn't just a scientific curiosity, it's a challenge. Every time we think we understand how objects interact in the Kuiper Belt, these two remind us how much we still have to learn. Their chaotic dance could rewrite the rules of orbital mechanics, or it might reveal forces at work in the outer solar system that we've never even imagined. Either way, they're proof that even in the coldest, darkest reaches of space, the universe still loves to keep us guessing. Amidst the frozen chaos of the Kuiper Belt, where most objects resemble lumpy, misshapen snowballs, one structure stands out like a cosmic dagger: the ice shard. This bizarre object isn't just another icy rock. It's a blade of pure, gleaming ice, stretching over 100 miles long but barely a few miles thick, as if some celestial force carved it with unnatural precision. Unlike the dusty, cratered surfaces of its neighbors, the shard's mirror-like exterior reflects sunlight with an eerie brilliance, making it one of the brightest objects in the outer solar system. But that flawless sheen raises more questions than answers. Why hasn't space dust coated its surface over billions of years? And how could something so fragile survive the violent ballet of cosmic collisions? One leading theory suggests the ice shard might be a monumental fragment of a shattered moon. Picture a Pluto-sized world, its icy crust fractured by a cataclysmic impact, sending razor-thin shards flying into the void. Over eons, most of those fragments would have ground down into rubble except this one. Its survival hints at an impossible strength, as if its ice isn't ordinary water but some exotic, hyper-compressed form we've never encountered. Spectroscopic scans reveal no traces of silicates or carbon, just pure, unblemished ice. That purity is its greatest mystery. In a region bombarded by micrometeorites, even the hardest ice should be pocked and scarred. Yet the shard's surface remains pristine, almost as if it's renewing itself. That's where the wilder theories kick in. Some planetary scientists argue the shard could be a frozen cryovolcanic plume, a monument to an ancient eruption. Imagine a geyser of supercooled liquid nitrogen or methane erupting from beneath an icy moon's surface, only to freeze instantly in the vacuum of space, preserving its knife-edge shape for eternity. If true, the shard wouldn't just be a relic, it'd be a snapshot of a geological process we've only glimpsed on moons like Enceladus or Triton. But even that explanation struggles with the dust problem. Cryovolcanoes spew particles, yet the shard's surface is eerily clean. Then there's the fringe idea that the shard isn't natural at all. Its unnatural geometry and reflective perfection have sparked whispers of artificial origins, though most astronomers dismiss this as wishful thinking. Still, the object's sheer improbability forces us to reconsider what's possible in the outer solar system. Whether it's a shattered moon fragment, a frozen eruption, or something even stranger, the ice shard defies categorization. It's a gleaming enigma, challenging our assumptions about how ice behaves in the deepest cold of space, and proving that even the simplest substances can become profound mysteries when cast into the darkness beyond Neptune. Hidden among the Kuiper Belt's countless tumbling icebergs, two objects stand apart, not for their strangeness but for their unsettling silence. Astronomers call them the Silent Sentinels, a pair of nearly identical orbs so still, so eerily motionless they seem frozen in time. Most objects in this distant realm betray some hint of activity, a wisp of gas escaping, a faint shimmer of surface frost, but the Sentinels nothing. No outgassing, no cracks, not even the faintest hint of a dust trail. Their surfaces are smoother than any known natural object in the outer solar system, polished to an almost unnatural perfection. What makes these twins so baffling isn't just what they lack, it's what they might be hiding. That flawless exterior could be the telltale sign of ancient cryovolcanoes long gone dormant. Imagine frozen titans that once spewed rivers of slushy ammonia or methane, their eruptions slowing over eons until their surfaces sealed shut, preserving them like cosmic time capsules. If true, their icy shells might cover vast underground oceans locked away beneath miles of pristine ice. But here's the puzzle. If they were once active, why do they show no scars, no remnants of past eruptions? Even dormant cryovolcanoes on moons like Europa bear the marks of their violent past. The Sentinels, though, are blank slates. Then there's the darker possibility that these objects aren't dormant at all but dead. Not lifeless in the biological sense, but geologically. They might be primordial relics, untouched remnants from the solar system's birth, so cold and undisturbed that they've never experienced so much as a tremor. Their mirror-like surfaces could be the original ice that condensed from the protoplanetary disk, frozen in place over 4 billion years ago. That would make them among the oldest surviving objects in our cosmic neighborhood, windows into a time before planets even formed. Yet their silence raises one chilling question: why only two? If such pristine fossils were common, we'd expect to find more. Their uniqueness suggests something extraordinary. Perhaps they were flung here from a region of space even more distant and undisturbed, or shielded by some long-vanished celestial barrier. Whatever their story, the Silent Sentinels aren't just curiosities. They're testaments to the quiet, forgotten corners of our solar system where time itself might have stood still. And that stillness, more than any eruption or collision, could hold the keys to understanding everything we thought we knew about how our cosmic backyard came to be. Deep in the frozen outskirts of the Kuiper Belt, something is fleeing. Meet the Runaway, an object hurling itself through space at speed so reckless, it seems determined to escape our solar system entirely. While most residents of this distant neighborhood drift lazily along predictable paths, this rogue traveler races against gravity itself, its trajectory angled sharply away from the sun as if flung by an invisible hand. Clocking in at nearly twice the velocity of its neighbors, the Runaway doesn't just move, it flees, leaving astronomers scrambling to explain what could have given it such a violent push. The first clue lies in its path. Unlike the looping orbits of typical Kuiper Belt objects, the Runaway's course is a near-perfect straight line, a cosmic highway with no exits. That kind of speed doesn't happen naturally, not out here where the sun's grip is weak and collisions are rare. One leading theory points to a gravitational slingshot, a chance encounter with an unseen world. Picture this: billions of years ago, a hidden planet, perhaps even a rogue interloper from another star system, swung too close to the Runaway. In a gravitational game of pinball, the smaller object could have been catapulted to its breakneck speed, vanishing into the dark before the solar system even finished forming. But there's a twist. Some researchers argue no known planet, hidden or otherwise, could account for such extreme acceleration. That's led to an even wilder idea. The Runaway might be a victim of galactic tides. Just as the Moon tugs Earth's oceans, the combined gravity of the Milky Way itself could have stirred the outer solar system long ago, plucking this object from its orbit and hurling it outward like a pebble tossed by a tidal wave. If true, the Runaway speed isn't just a fluke. It's a fingerprint of the galaxy's subtle but relentless influence on our cosmic backyard. Yet the most tantalizing possibility is that the Runaway isn't from here at all. Its trajectory aligns suspiciously well with paths predicted for interstellar objects, those rare visitors from other star systems. Could this be one of them, a wanderer that briefly got tangled in our solar system's gravity before resuming its journey into the void? Spectroscopic analysis might hold the answer. If its composition differs sharply from typical Kuiper Belt material, it could hint at origins far beyond our Sun's reach. Whatever the truth, the Runaway's flight is a ticking clock. At its current speed, it's poised to cross the threshold into interstellar space within centuries, becoming one of the few objects we've caught in the act of leaving. That makes it more than a curiosity. It's a living lesson in escape velocity, a reminder that even in the quietest corners of the solar system, forces are at work that can send worlds careening into the unknown. And by the time we unravel its secrets, it might already be gone. In the frozen darkness of the Kuiper Belt, where most objects glint with faint reflections of sunlight, one anomaly stands apart: the black diamond. This shadowy enigma doesn't just hide in the dark, it devours light, reflecting less than 2% of the sunlight that touches its surface. To the unaided eye, it would appear as little more than a hole punched through the fabric of space, a void where an object should be. But this isn't just cosmic camouflage, it's a clue to one of the most unusual compositions ever found in the outer solar system. The black diamond's near-total darkness points to a surface richer in carbon than anything we've encountered this far from the Sun. Spectroscopic analysis reveals hints of graphite, complex organic molecules, and even traces of diamond-like carbon materials more commonly associated with the crushing pressures of a planetary core than the icy outskirts of our solar system. That's led to a startling theory. This object might be the shattered remnant of a rogue exoplanet's heart, a wandering core stripped of its mantle and exiled to the cosmic hinterlands. Picture a gas giant born around another star, torn apart by gravitational chaos, its dense, carbon-rich center flung across the galaxy until our Sun's gravity caught it billions of years ago. Yet the diamond's survival defies logic. In a region where collisions should have ground it to dust over eons, this object remains intact, its surface eerily unblemished. One explanation lies in its possible structure, not a loose rubble pile like most Kuiper Belt objects, but a solid, monolithic slab forged under extreme pressure. If it truly is a planetary core fragment, its density could have allowed it to plow through lesser bodies like a bullet through tissue paper, leaving it unscathed while lesser objects shattered in its path. Then there's the mystery of its origins. If the diamond is indeed a visitor from another star system, its chemistry could rewrite the story of how common such interstellar interlopers really are. But another possibility is even more intriguing. What if it's a relic from our own solar system's violent youth? Some models suggest the early Sun's protoplanetary disk might have hosted ultra-dense carbon worlds, later destroyed in the chaos of planetary formation. The diamond could be the last survivor of a lost class of objects, a fossil from a time when the building blocks of planets were far stranger than we ever imagined. What makes the black diamond so captivating isn't just what it is, but what it represents, a challenge to our understanding of how planetary systems form and evolve. Its darkness isn't emptiness, it's a mirror held up to the gaps in our knowledge, reflecting just how much we still have to learn about the shadowy frontiers of our own cosmic neighborhood. Of all the oddities lurking in the Kuiper Belt, few spark as much intrigue or outright disbelief as the so-called hollow moon. This enigmatic object, roughly the size of Earth's moon but with just a fraction of its density, behaves less like a solid body and more like a cosmic echo chamber. When radar pulses were first bounced off its surface, the signals returned scrambled, fragmented, as if they'd ricocheted through a labyrinth of unseen voids. Subsequent calculations only deepened the mystery. Based on its gravitational pull, this world shouldn't feel hollow. It should feel empty. Like a spun sugar shell in the shape of a moon, its mass is concentrated in an improbably thin outer layer, with interiors so cavernous they defy conventional geology. How does something like this form naturally? One prevailing theory points to a dramatic past. Billions of years ago, the hollow moon might have been a standard icy body, rich in volatile compounds like methane and ammonia. Then, perhaps due to tidal heating or radioactive decay, its core warmed just enough to trigger a subsurface explosion, a slow-motion detonation that vaporized its innards without fully rupturing the surface. The result, a frozen balloon, its icy crust now the only remnant of what was once a more substantial world. Supporting this idea are spectral hints of exotic ices along fractures in its surface, possibly the last traces of gases that bled out during this catastrophic hollowing. But not everyone's convinced by the cosmic boiler explanation. Some researchers point to the object's bizarrely uniform shell thickness, too precise for a random blowout, and propose an even wilder origin. Could it be the remnant of an ancient subsurface ocean, one that froze, expanded, and left behind a honeycomb of chambers as the water crystallized? On moons like Europa and Enceladus, we see how liquid water can carve hidden worlds beneath the ice. But those oceans persist because of ongoing tidal forces. Out in the Kuiper Belt, where energy is scarce, such features should have collapsed eons ago. Yet here they are, preserved with eerie perfection. Then, of course, there's the fringe hypothesis, the one that makes astronomers groan and conspiracy theorists lean in. The hollow moon's geometric radar echoes, some insist, resemble the signatures of engineered structures. Could those chaotic internal reflections be the result of deliberate architecture, like vast support beams or collapsed chambers? Most scientists dismiss this as pareidolia, the human tendency to see patterns where none exist. But the object's existence does raise a legitimate question. If natural processes can create something this strange, what else might be possible in the universe's darker corners? For now, the hollow moon remains a paradox. It's either a freak accident of celestial mechanics or evidence of phenomena we've yet to understand. Either way, its very existence forces us to reconsider what's possible in the frozen fringes of our solar system, and whether nature, left to its own devices, might build stranger things than we could ever invent. Among the countless frozen wanderers drifting through the Kuiper Belt, none burn brighter or more mysteriously than the Phoenix pair. These twin objects spend most of their time as dim, unremarkable specks, barely visible against the blackness of space. Then, without warning, they ignite. For days or even weeks, their brightness can skyrocket by a factor of 1,000, blazing like dying stars before fading back into obscurity. These aren't random flickers, they're predictable, cyclical events, as if some hidden cosmic timer triggers their brilliant rebirths. What could possibly explain such dramatic flares in a region where temperatures hover near absolute zero? One leading theory points to cryovolcanism, volcanoes of ice instead of fire. Picture vast reservoirs of liquid nitrogen or methane trapped beneath frozen crusts, pressurized over millennia until the strain becomes unbearable. When the ice finally fractures, these supercooled liquids erupt into the vacuum, instantly vaporizing into towering plumes that catch the distant sun's light. On moons like Triton, we've seen similar, if far weaker outbursts, but the Phoenix pair's eruptions dwarf anything observed elsewhere, suggesting forces at play we've yet to fully comprehend. Yet cryovolcanism alone struggles to explain the pair's eerie synchronicity. These objects orbit separately, sometimes millions of miles apart, yet their brightening events often occur within hours of each other. That level of coordination implies something deeper, perhaps tidal forces from an unseen massive body flexing both objects simultaneously, or shared subsurface oceans responding to cosmic triggers we can't yet detect. Some researchers even speculate the pair might be remnants of a single shattered world, still connected by hidden geophysical echoes from their violent separation. Then there's the light itself. When the pair flare, their spectra reveal unnatural spikes in specific wavelength patterns unlike any known ices or gases in the Kuiper Belt. That peculiar signature has fueled fringe theories, including the tantalizing, if improbable, idea of reflective surfaces intentionally angled toward Earth. Could these be vast mirrors, perhaps remnants of an ancient effort to communicate? Most scientists dismiss this as fantasy, attributing the anomalies to exotic molecular structures forged in the outer solar system's extreme cold. But the data leaves room for doubt, and that ambiguity is what makes the Phoenix pair so compelling. Whether natural phenomena or something stranger, these periodic fireflies of the Kuiper Belt force us to confront the limits of our understanding. Their brilliance isn't just light. It's a challenge illuminating how much we still have to learn about the dynamic, unpredictable nature of even the coldest corners of our solar system. Out there, drifting in the Kuiper Belt's perpetual twilight, rests an artifact so ancient it might as well be a fossil, the time capsule. This primordial relic isn't just old, it's pristine, its surface untouched by solar winds, unmarked by cosmic rays, as if the universe itself forgot it existed. Unlike the battered, radiation-scarred faces of most objects in the solar system, the time capsule's icy shell gleams with the same chemistry it had 4.5 billion years ago, a snapshot of the raw ingredients that birthed the planets. What makes this object so extraordinary isn't just its age, it's its isolation. In a region where gravitational nudges should have sent it careening into neighbors long ago, the time capsule has somehow dodged every collision, every near miss, as if occupying a celestial safe zone. Its orbit is a cosmic tightrope walk, perfectly balanced between the tugs of Neptune and the faint pull of passing stars. That stability has preserved it like a fly trapped in amber, offering scientists something almost unheard of: a direct sample of the protoplanetary disk's original recipe. And what a recipe it is! Early spectroscopic scans revealed molecules never before seen in the outer solar system: complex hydrocarbons, chains of amino acids, even traces of phosphorylated compounds. These aren't just curiosities, they're the building blocks of life frozen in time. If similar chemistry existed throughout the early Kuiper Belt, it could mean the raw materials for biology were far more widespread and far more durable than we ever imagined. Some astrobiologists go further, suggesting the capsule might hold clues to how life's precursors hitched rides on comets and asteroids, seeding inner worlds like Earth. But the real mystery is how it survived. Current models suggest the early Kuiper Belt was a demolition derby, with countless objects smashing together to form larger bodies. The fact that this delicate timepiece avoided destruction challenges everything we thought we knew about that chaotic era. One radical theory proposes it might be a refugee from an even more distant region, a relic of the Oort cloud's inner edge, gently nudged inward but never fully integrated into the Kuiper Belt's violent dance. Then there's the eerie perfection of its surface. Most ancient ices are pitted with micrometeorite scars or discolored by ultraviolet exposure, but the time capsule's exterior looks like it was polished yesterday. Some researchers speculate it might be self-healing, its surface layers subtly rearranging over millennia to erase imperfections, a property that, if confirmed, would redefine how we think about ice physics in deep space. Whether it's a lucky survivor or a cosmic anomaly, the time capsule isn't just an object, it's a message. a message from an era before Earth existed, before the Sun's planets took shape, when our solar system was just a swirl of dust and possibility. And as we study its unspoiled surface, we're not just looking at history. We're reading the first page of our own origin story, written in molecules older than the continents, older than the oceans, waiting in the dark to tell us how it all began. Somewhere in the Kuiper Belt's vast expanse, a cosmic daredevil plays a lethal game of chicken with Neptune, the orbit breaker. This audacious object doesn't just skirt the ice giant's gravitational influence. It slices straight through Neptune's orbital path like a blade, threading the needle again and again without ever being caught. In a solar system where gravity rules supreme, the orbit breaker's defiance is nothing short of miraculous. Most objects that stray this close to a planet either collide, get flung into deep space, or become trapped as moons. Yet this rebel somehow dodges every fate, dancing along the edge of disaster with precision that defies the odds. The secret lies in its peculiar orbit, a stretched, tilted ellipse that crosses Neptune's path at just the right angle and speed. Calculations show the orbit breaker arrives at the intersection point exactly when Neptune is on the opposite side of the Sun, a synchrony so precise it feels orchestrated. This isn't luck, it's orbital mechanics pushed to the limit. Some researchers argue such a path couldn't have formed naturally without outside help. One leading theory suggests the orbit breaker might be an immigrant, a rogue fragment from another star's Kuiper Belt that got tangled in our solar system's gravity during the Sun's early days. Its unusual trajectory could be the scar of that ancient capture, forever marked by its interstellar origins. But there's a competing explanation, one that ties into the hottest debate in planetary science. The orbit breaker's path aligns eerily well with predictions for how objects might behave under the influence of a massive, undiscovered ninth planet lurking in the outer solar system. This hypothetical world, often called Planet 9, could be shepherding the orbit breaker's orbit like an invisible conductor, ensuring it never strays too close to Neptune. If true, this unassuming object might be the key to proving the existence of a ghostly giant 10 times Earth's mass, hiding in the darkness beyond Pluto. Yet the mystery deepens when we examine the orbit breaker's composition. Spectral analysis reveals a mix of ices and silicates unlike anything else in the Kuiper Belt, with isotopic ratios that don't quite match local material. That anomaly fuels the captured object theory, but there's a twist. Certain chemical signatures suggest it could instead be a refugee from the inner Oort cloud, a region even more distant and enigmatic. If so, its journey to this precarious orbit would have taken billions of years, a slow-motion plunge into Neptune's domain. What makes the orbit breaker so compelling isn't just its audacious path, but what it represents, a test of our understanding of gravity itself. Every close call with Neptune should, by all rights, have altered its orbit over millions of years. The fact that it persists challenges our models of celestial mechanics, hinting at forces or phenomena we've yet to account for. Whether it's an interstellar hitchhiker, a planetary ghost's puppet, or something else entirely, one thing's certain: this cosmic tightrope walker is rewriting the rules of the game, and we're only beginning to grasp how. Amidst the frozen chaos of the Kuiper Belt, where most objects resemble jagged mountains of ice and rock, one anomaly gleams with unnatural perfection: the metal sphere. Radar scans reveal a shape so flawlessly round, it makes astronomers double-check their instruments. In a region where celestial bodies are typically lumpy and irregular, this object's polished symmetry stands out like a ball bearing dropped on a gravel road. But it's not just the shape that defies expectations. Its surface reflects radar like polished steel, a signature usually reserved for dense nickel-iron asteroids found much closer to the Sun. So why is a metallic sphere lurking in a realm dominated by ice? One plausible explanation points to a violent past. The sphere could be the shattered core of a protoplanet, a world that formed too close to the young Sun's heat, where metals remained molten long enough to coalesce into a perfect droplet before being flung outward by gravitational chaos. If that's the case, its presence in the Kuiper Belt would mark it as a refugee from the solar system's inner sanctum, a rare survivor of the celestial billiards game that shaped our planetary neighborhood. Supporting this theory are faint spectral hints of olivine and troilite minerals often found in metallic meteorites, as if the sphere's surface still bears the scars of its fiery birth. But not all researchers are convinced. Some argue the sphere's radar signature is too pure, too consistent, lacking the cracks and fractures expected from billions of years of cosmic bombardment. That unsettling smoothness has fueled alternative theories like the possibility it's a fragment from an even more exotic source. Could it be a piece of a Mercury-like world torn apart in some ancient collision? Or stranger still, a remnant of a hypothetical iron planet, a class of ultra-dense worlds theorized to form under extreme conditions but never observed? The sphere's composition might hold the answer, yet every attempt to study it in detail seems to bounce off its mirror-like surface quite literally. Then there's the whisper that makes astronomers shift uncomfortably in their seats, the suggestion that the sphere isn't natural at all. Its uncanny geometry and reflective properties have drawn comparisons to hypothetical interstellar probes, theoretical spacecraft designed to endure eons of deep space travel. While mainstream science dismisses this as speculation run wild, the sphere's existence does raise a legitimate question. How would we even recognize an artificial object in the Kuiper Belt if we found one? Nature has crafted plenty of oddities, but this one sits right on the edge of what seems plausible. Whether it's a planetary core fragment, a relic of cosmic violence, or something even more extraordinary, the metal sphere challenges our assumptions about how materials behave in the outer solar system. Its very presence suggests that the Kuiper Belt isn't just a junkyard of ice, it's a museum of the improbable, where even the most familiar substances can take on forms that leave us questioning what we think we know. The Kuiper Belt holds many strange secrets, but few are as unsettling as the Echo Cluster, a pair of objects that don't just sit silently in the dark, they whisper back. These two distant bodies emit eerie bursts of radio waves, faint echoes that ripple through space like ghostly signals from another time. What makes these transmissions so baffling isn't just their existence, it's their pattern. Unlike natural cosmic static, these pulses arrive in rhythmic sequences, almost as if they're responding to something unseen. One leading theory suggests the Echo Cluster might be remnants of a shattered moon with an unusual past. Picture a world once rich in superconducting ices, its core threaded with magnetic fields. If such a moon fractured, perhaps torn apart by tidal forces or a catastrophic collision, its fragments could have retained traces of that electromagnetic memory. Now tumbling through the void, their fractured metallic interiors might still vibrate with faint currents, generating radio echoes like a cosmic tuning fork struck long ago. Supporting this idea are traces of iron-nickel compounds detected in the cluster's spectral signature, materials known to amplify magnetic anomalies. But there's a twist. These echoes don't match known magnetospheric phenomena. Normally, charged particles trapped in magnetic fields emit predictable frequencies like the steady hum of Jupiter's radiation belts. The cluster's signals, though, shift unpredictably, sometimes sharp and staccato, other times drawn out into ghostly wails. That variability has led some researchers to propose an even wilder explanation: plasma geysers. On moons like Io, volcanic plumes ionize into swirling clouds that generate radio noise as they interact with magnetic fields. If the Echo Cluster once harbored cryovolcanoes spewing electrified slush, their remnants might still flicker with discharges, creating these phantom transmissions. Then there's the unsettling timing. Every 73 hours, like clockwork, the signals intensify, as if some cyclical process deep within these objects is winding up and releasing energy. That kind of regularity is rare in nature, yet too sluggish to suggest artificial origins unless, of course, we're glimpsing the dying pulses of something ancient. Could these be the last gasps of a broken machine, a relic from a civilization so long gone its very existence is etched only in faint radio echoes? Most scientists dismiss this as fantasy, pointing instead to resonant cavities within the object's natural chambers where trapped electromagnetic waves bounce and amplify at set intervals. Yet the echo cluster refuses to fit neatly into any category. Its dual nature adds another layer of mystery. Why too? If these are collision fragments, why don't other Kuiper Belt shards behave this way? And why do their signals occasionally synchronize, briefly harmonizing before diverging again? The more we listen, the more questions arise. Each echo carries not just sound, but a challenge to reconsider what's possible in the silent depths of our solar system's frontier. Whether shattered moon, plasma ghost, or something beyond our current understanding, one thing is certain: the darkness out there isn't silent, it's listening. And sometimes, against all odds, it answers back. Of all the Kuiper Belt's mysteries, few are as frustrating or as downright eerie as the case of the vanishing act. One moment it was there, a faint but unmistakable blip in telescope data, drifting lazily through the outer solar system. The next, gone, not dimmed, not obscured, but utterly erased from observation as if someone had flipped a cosmic light switch. And the strangest part, this wasn't some ancient event lost to time. It happened in modern astronomy's backyard, with multiple instruments trained on it, leaving researchers scrambling for explanations that still don't quite add up. Theories about what happened fall into three camps, each more unsettling than the last. The first suggests a catastrophic breakup, an object torn apart by some unseen force. Picture a loosely held together rubble pile, spinning too fast or straying too close to Neptune's gravity, suddenly fracturing into countless fragments too small to detect. But here's the hitch: even a violent disintegration would leave debris, a cloud of dust and ice lingering for years, yet follow-up scans showed nothing. No fading afterglow, no scattered remnants, just empty space where a world once was. Then there's the dust cloud hypothesis. Could the vanishing act have passed through some vast, unseen shroud of cosmic soot, a floating veil dark enough to swallow its reflection whole? In the outer solar system, where sunlight is already feeble, even a thin haze of carbon-rich particles might blot out an object's signature entirely. The problem: such clouds aren't invisible themselves. They'd absorb and irradiate heat, leaving infrared signatures our telescope should have spotted. Unless, of course, this wasn't just any dust, but something far stranger, an ultra-cold molecular fog with properties we've never encountered. But the third possibility is the one that keeps astronomers up at night. What if it never vanished at all? What if our instruments glimpsed something else entirely, a fleeting trick of the light, a software glitch, or worse, a real object that moved in ways our models said it couldn't? The vanishing act's last recorded position sat at the edge of observational limits, where noise and signal blur together. Maybe it wasn't a Kuiper Belt object at all, but an unknown transient, a rogue comet on a freak trajectory, or even an interstellar visitor that slipped away before we could confirm it. The most haunting question isn't just what happened, but why we haven't seen it again. In a solar system where everything leaves traces, where comets return, asteroids reappear, and even the faintest objects eventually swing back into view, the vanishing act's silence is its loudest statement. It's as if the universe handed us a single, cryptic clue, then closed the case forever. And that's the real lesson here. For all our technology, for all our models, some corners of the Kuiper Belt still play by rules we're only beginning to glimpse. One moment they're there, the next gone, leaving us to wonder if we ever saw them at all. Deep in the frozen reaches of the Kuiper Belt, an oversized cosmic wrecking ball spins wildly out of control, the tumbling giant. This behemoth isn't just rotating, it's caught in a violent, chaotic dance, flipping end over end like a runaway carnival ride while simultaneously rolling sideways, its axis of rotation shifting unpredictably with each passing orbit. Most large celestial bodies eventually settle into stable spins, like Earth's steady 24-hour rotation or Pluto's sedate tumble, but the tumbling giant, it defies all conventions, twisting through space with the grace of a torpedoed battleship, and somehow, against all odds, it hasn't torn itself apart. The first clue to its bizarre behavior lies in its shape, or rather, its lack of one. Radar mapping reveals a grotesquely distorted silhouette, bulging asymmetrically like a potato squeezed between invisible fingers. This irregular mass distribution creates what physicists call a non-principal axis rotation, where the object wobbles unpredictably as different parts of its uneven bulk tug against each other. Normally, gravitational forces would reshape such a monstrosity into a more stable ellipsoid over time, smoothing out the irregularities. But the giant's sheer size, estimated at over 1,000 kilometers across, means its own gravity is locked in a losing battle against its structural pandemonium. So how does something this unstable even form? One leading theory paints a picture of cosmic cannibalism. Imagine a series of slow-motion collisions between smaller Kuiper Belt objects over billions of years, each impact adding mass but also torque, like a snowball rolling downhill and collecting uneven clumps of ice. If these mergers happened at oblique angles, they could have imparted conflicting spins, leaving the final agglomeration spinning drunkenly. Supporting this idea are spectral hints of varying surface compositions across the giant's face, as if its body is a patchwork quilt of half-digested victims. But there's a glaring problem with this scenario: physics. An object this large with such extreme rotational energy should have shattered long ago from centrifugal forces. Unless, and here's where it gets interesting, its interior isn't solid at all. Some researchers propose the giant might be more rubble pile than monolith, a loose collection of boulders held together by feeble gravity and friction, allowing it to flex and absorb stress like a cosmic stress ball. That could explain its survival, but not the persistence of its wild tumble. Over millions of years, even rubble piles should settle into more stable rotations. Enter the dark horse theory, tidal bullying. The tumbling giant's orbit brings it periodically close to Neptune's gravitational influence, though never close enough to be captured. These repeated gravitational nudges could be acting like a cosmic hand, continually stirring the pot and preventing the giant from finding equilibrium. Think of it as a celestial version of spinning a quarter on a table, just as your fingertip can keep the coin wobbling indefinitely with well-timed flicks. Neptune's gravity might be the unseen force perpetuating this madness. Yet the most tantalizing possibility is that we're witnessing something far rarer, a planetary embryo frozen in time. During the solar system's violent youth, protoplanets frequently collided in spectacular mergers, some spinning wildly before eventually calming into the orderly planets we know today. The tumbling giant could be a relic of that era, a failed world that never fully coalesced, preserved in the deep freeze of the Kuiper Belt as a museum piece of primordial chaos. What makes this erratic colossus so mesmerizing isn't just its defiance of physics, it's the questions it forces us to confront. How many other cosmic oddities are spinning silently in the dark, rewriting the rules we thought governed celestial mechanics? And what might this unstable giant teach us about the messy, improvisational nature of how planets are born? One thing's certain: in a universe that often favors order, the tumbling giant is a glorious, unrepentant rebel, and its chaotic dance is a reminder that even in the coldest corners of space, nature still has a taste for anarchy. There's something hauntingly beautiful drifting through the Kuiper Belt, a celestial specter we've dubbed the ghost tail. Unlike the inert, frozen husks surrounding it, This enigmatic object trails a shimmering veil of ionized gas, a whisper-thin tail flickering against the void like a candle in the dark. What makes this phenomenon so baffling isn't just the tail itself. It's the fact that the ghost tail shows no visible signs of outgassing, no plumes or cracks where gas could escape. It's as if the tail materializes from nothing, a cosmic magic trick playing out in slow motion. The leading explanation points to hidden cryogenic geysers of supercooled nitrogen or methane burrowed deep beneath the object's icy crust, erupting through fissures too narrow for our telescopes to spot. On active moons like Enceladus, we've seen how these subsurface vents can paint space with shimmering curtains of gas. But out here, where temperatures plunge hundreds of degrees below freezing, such eruptions should have frozen solid eons ago. Unless, of course, the ghost tail harbors a secret heat source. Some researchers speculate tidal forces from an unseen companion. A small moon or even a dense, rocky core might be flexing the object's interior, generating just enough warmth to keep its buried geysers sputtering. Yet there's another possibility, one that turns our understanding of the Kuiper Belt on its head. The tail might not come from the object at all, but from its interaction with the solar wind. Picture this as charged particles streaming from the sun collide with the ghost tail surface. They could be kicking up minute amounts of volatile ices, creating a faint but detectable ion trail. It's a delicate dance, one that requires just the right balance of composition and solar exposure, a balance no other known Kuiper Belt object seems to strike. Then there's the wild card, the idea that the ghost tail isn't alone. Tiny, undetected objects could be orbiting it, their gravitational tugs stirring subsurface reservoirs or even colliding with it periodically, releasing bursts of gas like pinpricks in a balloon. We've seen similar dynamics in asteroid pairs, where a smaller companion's influence triggers unexpected activity. But in the Kuiper Belt, where distances are vast and objects often dark, such a partner could easily escape detection, leaving only its ghostly fingerprints behind. What makes the ghost tail so mesmerizing isn't just the mystery of its origin, it's the fragile, fleeting nature of the phenomenon itself. Unlike the raging jets of comets, this wispy trail exists on the knife's edge of visibility, a reminder that even in the coldest reaches of our solar system, there's still movement, still change. Whether it's hidden geysers, solar whispers, or the hand of an unseen partner, one thing's certain. This ethereal streak of light is proof that the Kuiper Belt isn't the graveyard we once thought. It's a place where the dead still whisper, and if we listen closely, they might just tell us how. In the silent expanse of the Kuiper Belt, where most objects wear the dull, pockmarked faces of ancient ice, two anomalies gleam like cosmic funhouse mirrors, the mirror twins. These near-perfect duplicates don't just reflect sunlight, they throw it back with an almost mocking precision, their surfaces so polished they rival man-made telescopes. What makes them truly uncanny isn't just their shine, it's their symmetry. They orbit in flawless lockstep, maintaining the same distance, the same angle, as if tethered by invisible threads. At first glance, the twins' brilliance seems impossible. Natural objects this far out should be cloaked in layers of cosmic dust, their surfaces dulled by eons of micrometeorite impacts. Yet these two defy expectation, their exteriors unscarred, as if freshly buffed. One theory suggests a relentless sandblasting effect, tiny particles striking at just the right angle to erode imperfections without leaving marks, like a celestial version of wind-smoothing stone. Over billions of years, this process could have sculpted their surfaces into natural mirrors. But here's the catch: no other known Kuiper Belt object exhibits this phenomenon. If micrometeorites polished the twins, why are their neighbors still rough and shadowed? Then there's the synchrony. Their orbits aren't just similar, they're mathematically precise, maintaining a fixed separation that defies gravitational randomness. Normally, binary objects drift apart over time, their orbits perturbed by passing stars or planetary tugs. The twins, though, seem immune to these forces, their dance uninterrupted. Some researchers propose they might be fragments of a single, shattered progenitor, their shared velocity and composition locking them into this eerie harmony. Imagine a massive icy body struck by a colossal impact, fracturing into two near-identical shards that inherited its spin and trajectory. But another possibility lurks in the shadows, one that straddles the line between science and speculation. Their reflective perfection has drawn comparisons to theoretical solar sails, hypothetical spacecraft designed to harness light pressure for propulsion. Could these be relics of some ancient starfaring civilization, their mirrored surfaces intended to catch stellar winds? While mainstream astronomy dismisses this as improbable, the twins' oddity forces us to confront an uncomfortable truth. Nature rarely produces such perfection without reason. Even if they're natural, their existence challenges our understanding of how materials behave in deep space. What makes the mirror twins so unsettling isn't just their brilliance or their synchronicity, it's the way they force us to question our assumptions. Are we looking at a freak accident of cosmic erosion, a frozen monument to some long-forgotten collision, or something else entirely? In a universe where answers often lead to more questions, these gleaming enigmas remind us that even the simplest reflections can hide the deepest mysteries. Deep in the Kuiper Belt's frozen wilderness lies an object that shouldn't exist: the dark heart. This cosmic paradox doesn't just challenge our understanding of outer solar system objects, it mocks it. Radar scans reveal a nightmarish inconsistency: regions of staggering density, packed against voids so deep they register as cosmic potholes, as if something tore the object apart from within and hastily stitched it back together. Imagine a planetoid-sized Swiss cheese, but where the holes aren't empty, they're filled with shadows so dense they warp the very signals we use to study them. The dark heart's density map reads like a bad medical scan. Some sections clock in at over 5 grams per cubic centimeter, comparable to iron-rich asteroids from the inner solar system, while adjacent zones barely register above the density of powdered snow. This isn't just unusual for the Kuiper Belt, where objects typically have uniform, icy compositions. It defies basic planetary formation models. One leading theory suggests we're looking at a celestial Frankenstein, a rubble pile on steroids where fragments of radically different origins collided and stuck together in the solar system's chaotic youth. Picture the aftermath of a cosmic demolition derby, where shards of metallic protoplanet cores got tangled with fluffy ice boulders, creating this patchwork monstrosity. But there's a darker, more tantalizing possibility buried in those density spikes. The ultra-dense patches bear spectral signatures unlike anything native to our solar system, hints of rapid neutron capture elements like gold, platinum, and tellurium. These are the fingerprints of extreme astrophysical events, the kind forged in neutron star collisions or supernova shockwaves. That's led to a radical hypothesis: the dark heart might contain interstellar shrapnel, debris from a neutron star merger that happened light years away, later snagged by our sun's gravity as it passed through a dense molecular cloud. If true, those dense knots could be fragments of degenerate matter, surviving chunks of a stellar corpse's crust that somehow endured billions of years in the void before getting embedded in this icy oddball. Yet the most unsettling feature isn't what the dark heart contains, it's how it holds together. An object this fractured should have disintegrated under its own rotational stress or been torn apart by Neptune's gravity during close passes. Instead, it clings to cohesion with unnatural tenacity. Some researchers speculate it might be laced with exotic ices acting as cosmic glue, forms of methane or nitrogen crystallized under pressures we can't replicate in labs. Others propose electrostatic forces between its disparate components could be creating a fragile equilibrium, like a sandcastle held together by static cling. What makes the dark heart so compelling isn't just its defiance of physics, it's the questions it forces us to confront. Are we looking at a celestial accident, a one in a trillion fluke of cosmic recycling, or evidence of processes we've never imagined operating in our solar system's frozen outskirts? Every anomaly in its structure whispers of origins beyond our current models, a reminder that even in our own cosmic backyard, the universe keeps secrets written in languages we're only beginning to decipher. And locked within those dense, dark knots might lie answers, not just about this object, but about how the raw materials of worlds get scattered across star systems, waiting to be pieced back together into something new, something strange, something like the dark heart itself. Drifting through the cosmic void with no neighbors for billions of miles, the lonely wanderer is the Kuiper Belt's ultimate outsider. While most objects in this distant realm cluster together like shy partygoers, this enigmatic traveler floats in near total solitude, so far from the pack that spotting it was like finding a single grain of sand on an endless beach. Its orbit stretches so wide, so elliptical, that at its farthest point the sun would appear as just another faint star in the blackness. This isn't just isolation, it's exile on a cosmic scale. What makes the lonely wanderer so fascinating isn't just its distance, it's the question of how it got there. Most Kuiper Belt objects are thought to have formed in place, icy leftovers from the solar system's birth. But this one's path is so stretched, so improbably tilted, it looks like it was thrown, not born. That's led to two competing theories, each more intriguing than the last. The first suggests we might be looking at a hitchhiker from another star. Billions of years ago, when our sun was still nestled in its stellar nursery, close encounters with neighboring stars could have swapped debris between infant planetary systems. If true, the wanderer's chemistry should betray its origins, perhaps rich in isotopes unseen in our solar system, or lacking the fingerprints of our sun's unique nuclear furnace. But there's another, equally compelling possibility. This could be our first glimpse of the Oort cloud's frontier, that hypothetical shell of icy debris thought to encase the solar system like a bubble has never been directly observed. Its inner edge should begin where the Kuiper Belt fades precisely where the wanderer roams. If this object is a refugee from that mysterious region, perturbed inward by a passing star's gravity long ago, its composition could be a time capsule from the solar system's outermost reaches. Imagine tasting the first snowflake from a storm that's always been just over the horizon. Yet the wanderer's most haunting quality is its silence. Unlike active Kuiper Belt objects with their geysers and outbursts, this one sits motionless, its surface untouched by solar warmth or internal heat. Spectroscopic readings show no trace of volatile ices, no nitrogen, no methane, just ancient water ice as pure as the day it froze. That pristine surface suggests two chilling possibilities. Either it's been locked in the deep freeze since the solar system's birth, never warmed enough to crack or vent, or it's spent eons drifting through interstellar space, its original volatiles long since boiled away by cosmic rays. The lonely wanderer doesn't just defy categorization, it forces us to redraw the maps of our own cosmic backyard. Is it a messenger from the stars, a scout from the Oort cloud, or something else entirely? Every answer slips through our fingers like shadow, leaving only one certainty. In the vastness of space, sometimes the most profound discoveries aren't about what's out there together, but what's out there alone. Among the Kuiper Belt's countless drifting mysteries, none keeps time quite like the clockwork orb, an object that defies probability by ticking in perfect sync with Earth itself. While most distant bodies follow their own chaotic rhythms, this icy enigma completes one orbit around the Sun every 365.25 days, matching our planet's annual journey down to the decimal. It's as if the cosmos set two metronomes spinning billions of miles apart, and against all odds they never miss a beat. At first glance, this synchronization seems like a fluke, a numerical coincidence so precise it borders on the absurd. But orbital mechanics rarely do coincidences. The leading theory points to something called resonance, a gravitational ballet where distant objects influence each other's paths across staggering distances. Picture Neptune, massive and patient, gently tugging the clockwork orb into rhythm over eons, like a pendulum slowly synchronizing with vibrations in the floor. Yet even this explanation strains credulity. For such exact timing to emerge naturally, the orb would need to occupy a gravitational sweet spot, so precise that even minor disturbances, a passing star's nudge, a long-ago collision, should have disrupted it. The fact that this harmony persists suggests forces at work we've yet to fully grasp. Then there's the orb's composition, which deepens the riddle. Spectral analysis reveals a surface laced with metallic isotopes rarely seen in the Kuiper Belt: nickel, iridium, even traces of tungsten. These are materials forged in extreme heat, more at home near the sun than in the frozen outskirts. One provocative theory suggests the orb might be a refugee from the asteroid belt, ejected outward during the solar system's violent youth and later captured by Neptune's gravity. If true, its journey was choreographed with freakish precision, arriving at just the right speed and angle to lock into this cosmic timekeeping role. But let's entertain the playful alternative. What if the clockwork orb isn't just keeping time but measuring it? Its metallic veins and unnatural rhythm have sparked inevitable comparisons to theoretical extraterrestrial artifacts, like some long-dormant celestial chronometer left ticking in the void. Mainstream science scoffs at such notions, yet the orb's very existence challenges us to reconsider what natural really means in a universe brimming with unlikelihoods. After all, if a pulsar's rhythmic flashes were discovered today without context, wouldn't they too seem artificially precise? Whether gravitational accident, migratory oddity, or something more esoteric, the clockwork orb serves as a reminder that the universe adores patterns even when we can't quite trace their origins. Its silent, steadfast orbit mirrors our own, a distant cousin stepping in time across the dark. And perhaps that's the most humbling lesson of all. In the grand cosmic dance, even Earth isn't always leading. Sometimes the rhythm comes from the unlikeliest corners of the sky. Among the Kuiper Belt's frozen enigmas, few stand out as vividly or as unnervingly as the so-called blood snowball. This crimson-streaked wanderer drifts through the void like a celestial wound, its surface stained with patches of deep red that seem almost organic against the pale ice. Spectroscopy reveals something even more startling: complex carbon chains, molecules that on Earth we'd associate with the building blocks of life. But here, in the deep freeze of the outer solar system, their presence raises one electrifying question. Are we staring at the fingerprints of ancient cosmic seeding, or something even stranger? The leading explanation points to Tholen's organic compounds forged when methane and nitrogen ices are zapped by cosmic radiation or ultraviolet light. These ruddy molecules paint Pluto's poles and tint Saturn's moon Titan, so finding them in the Kuiper Belt isn't entirely shocking. But the blood snowballs Tholens are different. They cluster in concentrated, almost geometric patterns, as if something guided their formation. That odd distribution has led some researchers to propose cryovolcanic origins. Picture subsurface eruptions spewing slushy organic rich fluids onto the surface, where freezing temperatures and relentless radiation bake them into these eerie stains. If true, this object could be a frozen fossil of chemical experiments gone wild, a testament to how complex chemistry can thrive even in the coldest corners of the cosmos. Yet there's a more tantalizing and contentious interpretation. Certain molecular signatures in the red zones resemble amino acids, the very stuff proteins are made of. That doesn't mean life. Of course, these compounds can form without biology, but their presence in such abundance raises the ghost of panspermia, the idea that life's ingredients might hitchhike across the galaxy on objects like this. Imagine the blood snowball as a cosmic courier, ferrying probiotic material from one star system to another. its frozen surface a library of chemistry that could, under the right conditions, spark something greater. It's a long shot, but if verified, this unassuming red-stained snowball might hold clues to how life's raw materials spread through the universe. Then there's the wild card, the stains themselves. Unlike the diffuse splotches on other Tholen-rich worlds, these appear almost deliberate, concentrated in sinuous rivers and pools. Some fringe theorists have half-jokingly, half-seriously, wondered if we're looking at remnants of some unfathomable alien ritual, a sacrificial altar frozen in time. Cthulhu jokes aside, even mainstream scientists admit the patterns are puzzling. More plausible is the idea of seasonal changes. Perhaps the red material wells up from below when the snowball's odd orbit brings it fractionally closer to the sun, only to retreat again into the depths. What makes the blood snowball so captivating isn't just its color or its chemistry, it's the sheer audacity of its existence. In a realm where we expected only inert ice and rock, here's proof that the outer solar system isn't just a wasteland. It's a laboratory, a canvas, a storyteller. Whether it's brewing life's precursors, preserving the aftermath of ancient eruptions, or hiding processes we've yet to imagine, one thing's certain. This crimson-stained oddball is a reminder that the universe never runs out of ways to surprise us. And if its stains really do hold the seeds of life, well, then the joke's on us. The cosmos might have been playing the long game all along. Of all the Kuiper Belt's mysteries, none sparks the imagination like the Gateway, an object that doesn't just sit in the darkness but seems to beckon from it. At first glance, it looks like any other frozen world, its surface craggy with ancient ice. But then you spot it, a yawning chasm stretching nearly a third of its diameter, its walls too smooth, too symmetrical, as if something bored straight through the heart of this distant wanderer. This isn't some jagged impact crater or chaotic fracture, it's a tunnel, a passageway vanishing into depths our instruments can't penetrate. Theories about what created this eerie feature split into two camps, the natural and the less so. On one hand, it could be the ghost of a colossal cryovolcanic event. Picture a river of superheated ammonia or methane erupting from the object's core, carving a molten channel through its icy shell before freezing into this hollowed-out scar. Similar tubes snake beneath the surfaces of moons like Europa, though none so starkly visible. But here's the hitch: cryovolcanic tunnels usually collapse under their own weight over time, their ceilings buckling in the relentless pull of gravity. The Gateway's passage remains stubbornly open, its arch intact as if engineered for purpose. That unshakable geometry has fueled whispers of something far more provocative. Could this be the remnants of an artificial structure, a buried facility, a transit hub, or even some ancient megaproject left to crumble in the void? The tunnel's near-perfect circular cross-section mirrors designs proposed for hypothetical space habitats, where stability depends on precise curvature. Of course, invoking intelligent origins is a leap, but the Gateway forces the question: how do we recognize design in a universe that sculpts its own wonders? Nature builds spirals and spheres with flawless precision. Why not tunnels? What makes this object a priority for future missions isn't just the thrill of speculation, it's the science. If natural, its interior could preserve a record of the Kuiper Belt's chemical evolution, shielded from radiation and micrometeorites for billions of years. Probe its walls and you might find primordial ices untouched since the solar system's birth, or complex organics cooked in its depths, if artificial. Well, the implications rewrite history. Even the cautious approach holds value. Studying how such a structure endures could revolutionize our understanding of material strength in low-gravity environments, informing designs for future off-world bases. Yet the Gateway's greatest intrigue lies in what we can't see. Radar scans hint at branching passages beyond the main artery, a labyrinthine network sprawling beneath the surface. Are these connected chambers, collapsed tunnels, or something else entirely? Until we send a mission, it remains a riddle wrapped in ice, a literal doorway to the unknown, waiting in the dark for someone or something to step through. Beyond the strange objects we can see in the Kuiper Belt, there's a deeper mystery, one we can't even lay eyes on. Astronomers call it the hidden pull, an invisible force yanking at the orbits of distant worlds, as if something massive lurks just beyond our sight. This isn't just a hunch, it's written in the paths of these frozen wanderers, their trajectories warped in ways that defy the gravity of everything we've catalogued. The math doesn't lie, something out there is playing puppeteer, and we have no idea what. The leading suspect, a ghost planet, dubbed Planet 9 by researchers. This hypothetical world could be 10 times Earth's mass, drifting on a stretched orbit so wide it takes 20,000 years to circle the Sun. Its gravitational fingerprints are all over the Kuiper Belt, clusters of objects with oddly tilted orbits, all pointing toward the same patch of empty sky as if beckoned by an unseen hand. The sheer scale of this potential world boggles the mind. If it exists, it would rewrite our solar system's map, proving we've overlooked a neighbor hiding in the dark. But not everyone's convinced. Some argue the anomalies could stem from observational bias, our telescopes peering through a narrow keyhole of space, missing crucial context that would explain the odd orbits. Others propose a more unsettling alternative, primordial black holes. These ancient relics, forged in the universe's first chaotic seconds, could be peppered through the cosmos, some no larger than a grapefruit but dense enough to bend light and skew orbits. The idea isn't as wild as it sounds. A black hole of just a few Earth masses would tug at the Kuiper Belt exactly as we're seeing, silent, invisible, and utterly lethal if you got too close. Yet the most intriguing possibility isn't a single massive object at all. What if the hidden pull comes from a swarm? Picture a cloud of icy mini-planets, none big enough to detect individually, but collectively massive enough to warp orbits through sheer numbers. This would explain why our surveys keep coming up empty. We're looking for a needle in a haystack when the haystack itself is the culprit. The truth is, we're stuck in a cosmic detective story with too many suspects and no crime scene. Every explanation has holes. Planet 9's orbit should have been spotted by now if it's where models predict. Black holes leave no light, but they should warp background stars, an effect we haven't seen. And a swarm of unseen objects raises its own questions. How did they form and why stay clustered? Perhaps the answer lies beyond our current tools. Or perhaps the universe is reminding us that some shadows, no matter how hard we stare, refuse to give up their secrets. The hidden pull isn't just a puzzle, it's a lesson. For all our telescopes and theories, the outer solar system remains a frontier where the rules we know might not apply, and where the darkness still has stories left to tell. These Kuiper Belt oddities aren't just cosmic curiosities, they're wrecking balls swinging through the foundations of planetary science. Every bizarre orbit, every inexplicable composition, every flicker of unexpected activity forces us to confront how little we truly understand about our own solar system's backyard. Take the Runaway's breakneck speed or the orbit breaker's gravitational ballet. These aren't just anomalies. They're screaming evidence that our models of planetary migration are incomplete. The textbook story of neat, orderly planet formation collapses when faced with objects that behave like they're following rules written in invisible ink. Consider the hollow moon's impossible geometry or the dark heart's patchwork density. These aren't just quirky formations, they're proof that materials in the outer solar system can assemble in ways our labs can't replicate. The very existence of ultra-dense metallic fragments like the metal sphere alongside porous, low-density oddities suggests the Kuiper Belt isn't some homogeneous junkyard of ice, but a sprawling cosmic pawn shop where objects from radically different origins got dumped together. This forces planetary scientists to rewrite the story of how building blocks were distributed during the solar system's birth. Maybe the protoplanetary disk wasn't the smooth gradient we imagined, but a turbulent mosaic where metals from the inner system mingled with ices from the far reaches in violent, unpredictable ways. Then there's the chemistry that defies expectation. The blood snowballs' organic stains and the time capsule's primordial amino acids challenge the notion that life's ingredients are rare or confined to the inner solar system. If complex molecules can form and persist in the deep freeze of the Kuiper Belt, the potential feedstock for life might be far more abundant across the universe than we dared hope. Suddenly, icy moons around distant gas giants or even rogue planets drifting between stars become plausible incubators for prebiotic chemistry. But perhaps the most consequential puzzle is the hidden pull. Whether it's Planet 9, a black hole, or a swarm of unseen objects, this gravitational anomaly exposes how blind we still are to our solar system's full inventory. Imagine mapping your hometown while missing an entire mountain range lurking just beyond the city limits. That's essentially where we are with the Kuiper Belt. Every unexplained orbital quirk is a signpost pointing to forces we haven't accounted for, maybe new physics, maybe undiscovered worlds, or perhaps something even stranger. This is why these mysteries aren't just academic, they're driving real missions and telescopes. The clockwork orb's perfect resonance makes it a priority target for spacecraft aiming to understand gravitational dynamics. The mirror twins' reflective surfaces have inspired proposals for lightweight space telescope mirrors using natural Kuiper Belt materials. Even the ghost tail's ethereal plume is shaping designs for future probes, teaching engineers how to navigate tenuous atmospheres around icy bodies. What's thrilling isn't just the questions these objects raise, but how they're reshaping our tools for answering them. Next-generation observatories like the Vera Rubin Observatory are being fine-tuned to spot more anomalies, while mission planners debate whether to send a probe to the Gateway's enigmatic tunnel or the Phoenix Pair's explosive eruptions. Each mystery is a catalyst pushing technology and theory further into the unknown. Because ultimately, the Kuiper Belt isn't just a collection of icy worlds, it's a hall of mirrors reflecting back all the assumptions we never realized were so fragile. And in that reflection, we're seeing not just our solar system's past, but the future of discovery itself. From the gray ghost's unnerving stealth to the clockwork orb's impossible precision, these 25 Kuiper Belt oddities aren't just cosmic quirks. They're full-blown revolutions wrapped in ice. Every crater, every erratic orbit, every flicker of unexplained light forces us to admit a humbling truth. We've barely scratched the surface of our own solar system. Think about it. We've mapped mountains on Mars, tasted the atmosphere of Titan, even landed probes on speeding comets. Yet out here, in this frozen junkyard at the edge of everything, nature keeps dealing wild cards that leave astrophysicists speechless. Take the contradictions alone, the hollow moon's impossible emptiness versus the dark heart's inexplicable density, the mirror twins' flawless symmetry against the tumbling giant's chaotic pirouettes. These aren't just random variations, they're proof that the outer solar system operates by rules we haven't decoded yet. And then there are the echoes of violence, the metal sphere's scarred metallic hide, the twisted twins' gravitational waltz of destruction, the ice shard's knife-edge silhouette, all frozen screams from a time when worlds collided and chaos ruled. But perhaps most thrilling are the whispers of activity where we expected only silence, the Phoenix Pair's periodic fireworks, the ghost tail's ethereal veil. Even the time capsule's eerie preservation suggests forces at work beyond our textbooks. These objects aren't relics, they're participants in a drama still unfolding, a reminder that the Kuiper Belt isn't some static museum exhibit. It's a living, breathing frontier where chemistry, physics, and maybe just maybe something even stranger are still writing their next acts, which brings us to the grandest paradox of all: the more we discover, the less we know. For every answer these enigmas provide, like the blood snowball's organic stains hinting at life's cosmic ingredients, they unleash 10 new questions. Why do some objects defy orbital logic while others move like clockwork? How can surfaces remain pristine for billions of years? And what unseen hands, be they ghost planets, black holes, or forces we've yet to name, are tugging at the strings from the shadows? That's the real magic of exploration. Not checking boxes on a list of facts, but standing awestruck before the vast unknown, reminded that wonder isn't a phase, it's the permanent state of anyone who dares to look up. So tell us, which of these cosmic rebels captured your imagination? The hollow moon's impossible architecture, the Runaway's desperate flight, or maybe the gateway's tantalizing tunnel inviting us to step into the dark? Drop your pick in the comments and keep looking up. The universe has only begun to surprise us.